Hey guys, it's Mrs. Cameron here, and we are on our SAT Math Digital Practice. We're on question number 22, which says a cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube. To the nearest cubic inch, what is the volume of the space in the cube not taken up by the sphere? So we have this cube where we take a square where all four sides are the same, and another square, and connect the corners. So length, width, height are all equivalent, all equal, all 68 inches because length, width, height on a cube are all the same, okay? And we also have a sphere with a radius of 34 inches. So from the middle to the edge, radius is 34 inches. And this sphere is inside the cube, and they want to know what is the volume of the space in the cube not taken up by the sphere. So we're going to take the volume of our cube and subtract out the volume of our sphere. And you can look on your reference sheet for this. Volume of a rectangular prism or a cube is length times width times height. And volume of a sphere is 4/3 pi r cubed. So my volume of my cube is length times width times height, which is 68 to the power of 3. Take away the volume of the sphere, which we said was 4/3 pi times the radius is 34 cubed, just like this. And now I can put this right in my calculator. 68, 68 to the power of 3, 68 cubed. My volume of my sphere, the volume of my cube, take away the volume of my sphere. Volume of the sphere is 4/3 pi times the radius, which was 34, and the radius needs to be to the power of 3 because it's a 3D figure. And the closest answer to my whole number answer choices is A. The 7 tells the 5 to go up to a 6 when we round it, so our answer is A. And there was no formulas you need to memorize for that. You just needed to be able to use the formulas that were provided to you on the reference sheet. And moving forward with question number 23. What is the diameter of the circle in the xy plane with the equation x minus 5 squared plus y minus 3 squared equals 16? So if you know your circle formulas, then you know that this over here on the edge is your radius squared, which means our radius is, the square root of 16 is 4. Our diameter is the radius times 2. So 4 times 2 is 8 is our answer. And if you are not familiar with circle equations, you can just take that equation and type it into the calculator. X minus 5 squared times y minus 3 squared equals 16. And take a look at your circle. My circle's not looking very circly. X minus 5 squared. Oh, I forgot a plus sign. That's why. Plus 7 minus, why did I say 7 minus 3? That should be y minus 3. Mrs. Cameron's tired. Go back home. Okay. And if we look here, if you look from edge to edge of your circle at the widest part, you can count the diameter. So we're going up 1, plus up another 5. That's up 6, up 7, up 8. So again, diameter would be 8. So you can figure that out by using the equation, or you can figure out your diameter by plugging the formula into your calculator and just counting across your circle at the widest part. And moving forward to question number 24, it says, for the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? So if we had, okay, so when f is 1, which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? So the base is the stuff that's not the exponent, right? So I would want it to be just the stuff that's to the power of x whatever, right? I want it to just be this. So how do we get back to the coefficient or the base? Anything to the power of what equals back to its equals back to 1, right? So we would want here, like if I put 5 to the power of 0, that equals back to 1. So if you look here, x minus 1, if f of 1 is k, then if you put in a 1, you've got 1 minus 1 is 0, and you're back to 128, which is going to give us our whole number, 128, and our correct answer here is C. And then let's keep moving on to question number 25. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. So we've got an exponential function where we're increasing 150%, and that's these two right here, not these two, okay? The model estimates that at the end of 2016, there were 180 squirrels in the population. Which of the following equations represents this model where n is the number of estimated years of squirrels in the population t years after the end of 2015, and t is less than or equal to 5? So my number they gave us here is not our starting point. at the end of 2015, it's a year later. So it can't be where we have 180 as the starting point. It needs to be less. And the only option that's left is A, which is the correct answer. And now we've got 2 more questions. And we're getting, towards the end of the section. These are going to be the harder questions. So I'm trying to move a little bit faster through these. And I'm hoping that my students are not spending a whole lot of time on these questions, because my students' goal is not necessarily to work really hard on the hard questions, but to make sure you're getting the questions towards the beginning correct. Question number 26 says, in the given pair of equations, A and B are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? And if we look here, we can see that, okay, A, B, then our slope here would be -5 over, divide both sides by 7. And if you look at this one, the perpendicular slope would be negative A over B and let's see, if you look here, 10x and 7a minus 2by. If these are perpendicular, everything's positive. B and C both has everything positive, so I'm going to eliminate A and D. And then I'm going to look here, and A, B, 5 and the B are across from each other. 5 and the B are across from each other. 10 times 2, these are corresponding. This is twice as much. I'm going to go with B for my answer, because look how 10 is 2 times B. And over here, these are across from each other. So 2 times B turns 5 into 10. That works. And the 7 and the 7 didn't change. So the A would just stay 1A. And B is, answer choice B is the correct answer. And our last question on this SAT practice, in the given equation, C is a constant. The equation has no real solutions if C is greater than N. What is the least possible value of N? So x squared minus 34x plus C equals 0. So we would have no solution if the discriminant was a negative. And this discriminant is a piece of your quadratic equation, which they do not give you the quadratic equation on the SAT. So negative b plus or minus the square root of b squared minus 4ac over 2a. This is your quadratic equation that you would need to have memorized, and there's no real solution if you have a negative inside of your discriminant here, inside of this square root. So b is negative 34, so negative 34 squared minus 4 times a is 1, and c, well, it's c. So if this is negative, so when I multiply negative 34 squared is 1,156. minus 4c, and I need this to be less than 0.